The next series of signals use two-wire jumpers. The signals are credenza recorder input, alarm relay input, alarm relay output. The credenza recorder and alarm relay inputs, as well as the relay output, are colored green on this loop diagram. The green wires are the jumpers mentioned, and the circuits we will complete next. How did we know to use jumpers instead of cable? Look at the typical wiring for a transmitter block. Notice terminals 2D and 3D. The wires are designated 2C number 22. This means two-conductor number 22 gauge wire. This is two-conductor number 22 gauge jumper wire. The accompanying notation on the transmitter block drawing states, to remote recorder where required, typical. For our loop, we connect a jumper from TB256-1, terminals 11D and 12D, to TB254-1, 1D and 1B, for the credenza recorder input. Run and connect the jumper. It is not necessary to continuity check the jumpers. However, be sure to tag the wires. The alarm input is also shown on the typical transmitter block. Locate the alarm relay. It is the fifth chassis in group 251-2. Here is the alarm relay in cubicle K1, the fifth relay in the second group of relays. Pull the relay card before you terminate the wires. The relay must be reinstalled during loop checkout. Run and terminate the jumper. The wiring between TB254-1 and the credenza recorder is already complete. However, it should be checked for continuity and polarity. Locate credenza recorder 1. Attach one buzzer lead to terminal 22 and attach the other lead to ground. Ground either TB254-1, terminal 1D, or TB256-1, terminal 11D. You can see the continuity path on the loop diagram. Check the other lead in a similar manner. The wiring between TB253-1, terminals 25D and 17D, and the panel-mounted alarm is also complete. It must be tested. As stated before, some of this equipment is working. This alarm unit, called a pan alarm, is one of the pieces of equipment that is working. Therefore, we will use a different technique to test the wiring between the alarm unit and the relay chassis. The wires we must test are the orange and brown multi-pair cable wires. The orange wire terminates on plus. The brown on 25L terminal 2-3A. The unit is located on the left side of panel 25, hence 25L. The designation 23A means the alarm window is in horizontal group 2. Vertical row 3. Window A. Locate the window on the unit. Window 2, 3A. Use a panel annunciator electrical wiring diagram to locate the wires. This drawing shows the back of the annunciator. Locate the plus wire, which is orange. Locate 2, 3A, terminal SA. The wire should be brown. The back of the panel arm is laid out just like the front. Find horizontal 2, vertical row 3. Window A or SA terminal. This is where the brown wire should be. Check the continuity by hooking the buzzer from TB253-1, terminal 25D, to the plus lead on the back of the panel arm unit. You may have to use a jumper to extend one of the buzzer leads. This method enables you to check continuity of working low-voltage circuits without breaking the circuit or grounding it. Grounding a live circuit can blow a fuse. Check the continuity of the brown wire in the same manner. The tripmatic and panel arm wiring is now complete. More will be said about alarms in a later lesson. Complete the jumper between controller terminal 9 and recorder terminal 14. The line from controller terminal 2 to recorder terminal 2 represents signal common. It is already existing. Mark the wiring that is complete. Now work exercise number 7 in your workbook. The remaining portion of the loop wiring consists of computer wiring. Process value and valve position feedback are examples. The process value the computer senses comes from the transmitter block TB256-1 and goes to TB43-1. Notice TB43-1 is located in cubicle P1. TB43-1 is a computer analog block, so named because it terminates the 1 to 5 volt analog signals. Notice terminals 4A and 4B, and the wire colors, blue, black. Here is a wiring diagram for a computer analog block. Notice terminals 4A and 4B. They have blue-black wires. Follow the wires from 4A and 4B. The wires are in a cable that goes to a transmitter block. The wires are further identified as terminating on 11D and 12D of the transmitter block. The loop diagram confirms the termination point. Terminate the wires at TB43-1, the computer analog block. Do not terminate the wires at TB256-1 yet. Look once again at the computer analog block. 2-wire jumpers leave the block. The loop diagram shows you where to terminate the jumpers, TB43-1, 4A, and 4B, to TB41-1, 25C, and 25D. Locate the cable, and then locate the orange-white pair at frame 23, location C, and at TB41-1. You may have to find the right cable by looking at the cable tags. Terminate the orange-white pair at TB41-1, terminals 25C and 25D. Check each wire for continuity. Short the orange wire to ground at frame 23. The wire must not be hooked up to the computer when you are checking continuity by grounding wires. Hook up the wires at the computer after you verify continuity. Attach the buzzer to the blue wire at TB256-1. Check the white wire for continuity. Then terminate both ends of the pair. Complete the feedback circuit in the same manner. Use the loop wiring diagram and the computer analog block wiring diagram to find and to terminate the wires. Color the wiring that is complete. Now work exercise number 8 in your workbook.